Welcome to this video of another set of 10 CWI Part A questions. These are random questions with explanations provided that will guide you in your preparation for the CWI exam. So let's not waste any of your time and go into the video.
The presence of paint on the surface of a part will most greatly affect the results of which NDA method? Letter A, PT and MT. Letter B, RT and UT. Letter C, MT and ET. Letter D, UT and ET. Letter E, ET and VT. So the presence of paint can affect which of the following non-destructive testing. So that's basically what is being asked in this question. So the requirement of PT and MT is that the weld surface must be clean and that includes paint. So this presence of paint can cause false indication and the paint can also block the opening and thus the discontinuity cannot be revealed properly. So basically if you have a surface that is being blocked by the paint, then the discontinuity cannot be revealed. So the answer here is letter A, PT and MT. Fracture toughness results often be expressed in terms of letter A, breaking energy. Letter B, tensile strength. Letter C, percent elongation. Letter D, endurance limit. Letter E, reduction of area. So for the choices here, tensile strength is the capacity of the material before breaking. This is indicated or located in the ultimate tensile strength in the stress strain curve, right? So we have it right here. So before the rupture point. So the percent elongation is also known as strain or the ratio of the length and the original length. So this percent elongation is just basically the strain of the material. Endurance limit is the stress level below which a material can theoretically withstand an infinite number of cycles without failure. So endurance limit basically pertains to the fatigue or relates to the fatigue failure of the material. Reduction of area is the change in area when the material is subjected to tensile force. So can just imagine if you pull a material in its cross section, and eventually it will be reduced in its area. So the answer here is letter A, breaking energy. So this measures the fracture toughness of a material. So this can be measured by a bunch of testing procedures like CHARPY notch, IZAD, among those testing procedures. By the way, I just want to take a break from the video and remind you of the free Udemy course that I've put in the description down below. So it composes of CWI Part A lectures, the introduction for welding inspectors. So you can check out the description below for that free Udemy course. Now back to the video. If no information appears to the left of a groove weld symbol, this means A. No weld is required on that side. Letter B. The weld is to be complete joint penetration. Letter C. The weld is to be continuous for the entire length of the joint. Letter D. Beveling is not required. Letter E. Weld size is to be determined by the welder. So when there's a size or a number indicated in the left of a groove weld symbol, it means that the groove weld does not fill the entire joint. So if there's no information, that just means that the weld is a complete joint penetration, which is indicated here in the choice letter B. So for the choices here, A is just false. So there is a required weld on that side of the welding symbol. C, for letter C, there's no information on the right side of the weld symbol. So for this one, if the weld is to be continuous for the entire length of the joint, then it must be located on the right of the welding symbol or the weld symbol, not on the left. So beveling and the weld size to be determined by the welder is false as well. So the answer here is letter B. So to summarize this question, if it is on the left, if there's no information on the left of the groove weld, then it is a complete joint penetration. If there's no information on the right of the weld symbol, then the weld is to be continuous for the entire length of the joint. The property of a material, the property of a material that best relates to its resistance to impact loading is letter A, endurance limit, letter B, fatigue strength, letter C, fracture toughness, letter D, tensile strength, letter E, ductility. Endurance limit is the stress level below which a material can withstand an infinite number of cycles without failure. So that relates to the fatigue strength, which is also letter B. So tensile strength is the capacity of the material before breaking, as indicated in the stress strain curve. Ductility is the ability of the material to be deformed or elongate before breaking. So the property here that best relates to the resistance to impact is toughness, fracture toughness. So fracture toughness determines the material's resistance to impact, most commonly with high tensile strength materials and for those materials that are exposed to the cold temperature. So the answer here is letter C. Of the following discontinuities, which is most likely to be a flaw caused during the manufacture of steel? A, porosity, B, lamination, C, undercut, D, crack, E, inclusion slag. So for the choices here, porosity occurs due to the moisture or the presence of hydrogen in the weld. Undercut is where a notch is formed by a metal being melted away from the weld zone. So a crack is a serious defect that can lead to failure. So as you know, there are no acceptable forms of crack. If you see it, it's automatically a defect. Slag inclusion is the inclusion of a material in the weld metal. So this can commonly be, be formed when there's not enough cleaning in the weld. So for letter B, lamination normally happens when the steel is flattened during the rolling process. So during the rolling process, it can be considered as during the manufacturing process of steel. So the answer here is letter B, lamination. Which of the following is considered to be an advantage of VT or visual testing? Letter A, discontinuities can be located and noted when they occur. Letter B, it is capable of detecting subsurface discontinuities. Letter C, welders can accept their own work. Letter D, equipment can be expensive. Letter E, it can determine material strength. So if you can observe here, all of the choices have their own merits, right? But we have to select the best answer here. So the big advantage of visual inspection is that it can detect a discontinuity before the welder puts on another pass in the weld. Just an example, right? So for letter B here, it is just not possible with the naked eye and without the assistance of other NDT methods. So you cannot detect subsurface discontinuities with your own eyes because it is hidden. So letter C, you want to avoid this. Welders can accept their own work because there must be an oversight with the welder's work in order for a proper quality control procedure to happen. Letter D, equipment can be expensive. So yeah, definitely. Equipment is expensive, but there are other defects that be best done by, for example, X-ray or RT or UT. Just an example. But this is not an advantage of VT because having different NDT methods have their own advantages, right? So this is not the main advantage for visual testing. So because there are other more effective NDT methods that are more appropriate for a specific kind of discontinuity to be detected. You cannot determine the material strength by just looking at it. So you have to, it needs to be tested or uh, for example, it must be subjected for under a tensile strength machine. You cannot determine it by just looking at it. So the answer here is letter A. Discontinuities can be located and noted when they occur. So that gives value to the uh, welding proceed or welding the entire welding procedure because you can detect the early signs of failure before it even or before it got it will be hidden because another pass of weld is done. So you can do that by having a hold point in the inspection test plan if that weld is to be a critical one. When a weld has been rejected by a qualified NDE technician, the welding inspector should Letter A, review the test results and maintain the test record. Letter B, re-inspect to verify the defect. Letter C, accept the weld if its visual appearance is in compliance with the applicable code or specification. Letter D, require another inspection by a third party. Letter E, accept the weld since it is in a low stress region. For letter B, no need to inspect if the weld has already been rejected by a qualified NDT technician. So this is just counterproductive already. So letter C, this is a big no because the code will not allow this in the first place. Because the first basis of a weld acceptance are actual measurement of the discontinuity as you see it in the weld. Letter D is just expensive and unnecessary. So you don't need another inspection by a third party unless otherwise you have a dispute with the first ND inspector. So that's just not very efficient or very cost effective. And letter E, we don't have enough information for letter E to be true. So the answer here is letter A. So this goes back to the responsibility of the welding inspector to review the test results done by the NDT technician and maintain the test records. So if there are any disputes or, for example, any code violation or whatnot that has been reviewed by the welding inspector, then he should take it up with the NDT technician. But if it is all good, because it is not stated in the question that there are any discrepancies, so the best answer here is letter A. If equal thickness of steel, cast iron, aluminum, lead, and copper are radiographed using the same exposure conditions, which material will result in the darkest radiograph? Letter A, lead. Letter B, steel. Letter C, aluminum. Letter D, copper. Letter E, cast iron. So this question will test your knowledge of the output of these radiographic films. So the less dense material will produce the darkest radiograph. This is why hollow points in the radiograph are also the darkest. Hence, there's discontinuity there. So if there are lighter points that you see there, lighter indications, so that means there are discontinuity, right, in the film. So if you are familiar with the densities of these materials, so you can know that the least dense out of all the materials here are or is aluminum. So the answer here is letter C. So the least dense material will produce the darkest radiograph among these choices. All welding symbols require which of the following basic elements in their construction? Letter A, reference line, arrow, and tail. Letter B, reference line and arrow. Letter C, reference line, arrow, and weld symbol. Letter D, reference line, arrow, weld symbol, dimensions, and supplementary data. Letter E, reference line only. So the only necessary elements of the welding symbol are the reference line and arrow. All others are just optional. You cannot call a welding symbol without these two elements. So the answer here is letter B. Of the welding processes listed below, the one most commonly having the highest deposition is A. OAW or oxyacetylene welding. Letter B. FCAW, flux cord arc welding. Letter C. SAW or submerged arc welding. Letter D. SMAW. Letter E. GMAW. So the answer here is submerged arc welding, SAW. Because out of all the welding processes, this has the largest deposition because of its setup and the characteristic of this process, as it is an automatic welding process, unlike the other welding processes that you can see here, which is either manual like SMAW or GMAW, which is a semi-automatic process, and FCAW as well. So SAW is also operated by a welding operator, not a welder, which is aligned to be it becoming or to be it being in to be with it being an automatic welding process. So the answer here is letter C.